analysis on it. Okay, so the sequence analysis that we were doing, we want to look for similarities. Sequence analysis is about the study of similarities. So we're looking for similarities in those incidents. We're trying to identify the features of those incidents, and we're trying to identify the differences of those incidents. And how that applies to you in a commercial world, we'll kind of come on to a little later. So we were trying to find sequences, we were trying to find features, we were trying to find differences. Okay, so the software we were using to do that was the software package called R. So if I just come out of this presentation and drop into R. Now, as I said, this software is freely available. It's open source. You can download it yourselves. Excuse me. Sorry about that. You can download it yourselves. And having downloaded the R environment, you would then download the TrayMineR package, which would enable you to do the sequence analysis. Now, what I'm going to do here is I'm going to run through the code that we've used to do the sequence analysis. And at a certain point, I am going to stop and switch back to PowerPoint slides. The reason for doing that is quite simple, that if I ran the entire analysis, it would take far too long, much longer than we've got to do this presentation. So, first of all, I need to kind of tell the software that I want to use the TrayMineR library. So, I give it the command library TrayMineR, and R is case sensitive. So if you're having problems, it may be that the case is incorrect. So we want to use the functionality of the TrayMineR, and I want to tell the software that actually this is the package that I need to use. So I want to require that software. Now that I've got an extraction of the data, I've got that out of the database of the fire service, and I've got that saved as a CSV file on my desktop. So now I need to read in that CSV file and store that CSV file within the R environment so that we can use that. Okay. Okay. So what this command is doing, I've got an object variable, SYFR, into which I want to load the data. And then I'm telling the R software, the R package, that I need to read the table from this file, the SYFR test.txt, and that is a CSV file. It's formatted CSV. The header is true, so there is a header within that file which identifies what the column names. I then define how the data is separated. In this case, it's separated by space, what an empty string looks like, and I want to fill all of the columns. So I say that I set that value to true. Okay. So having loaded the data in, I can summarize it and just to have a quick look, just to be sure that the data has loaded into the R environment, and we can see there that the data has come in. How do I know that it's come in? Because I'm being shown this blue text. If the data hadn't got in, I would obviously be shown an error message. Okay, so now that we've got the data into the R environment, we need to now create a sequence object. Remember, we're looking at the sequences of this data. I want to look at the similarities, the dissimilarities of this data. So I need to create a sequence object, and that sequence object is what the TrayMineR package will use to perform all of the analysis against. So I can do that quite simply just by dropping in the sequence definition command. Okay, so what we're doing here is that we're saying I want a sequence definition, and I want you to store this sequence definition in this object called syfr.seq. The data that you're going to use is syfr, which is this object here, where we've loaded the data in from this CSV file. and the variable is null. So that tells R that it should utilize all of the columns within this data set when it's creating this sequence object. There are other values that I could put in this command, values to tell the package what it's going to do with missing values, what it's going to do with color schemes and things like that, but I don't need to do that. I'm quite happy that we've got in the information that we need. Okay, now for myself, for this data, we're interested in the similarity of various entities. How similar is one of those entries, one of those fire incidents, to another? Because ultimately I want to be able to group those entries based on their similarity. Now what I need to do in order to compare the similarity, in order to group them, is I need to calculate the distance, the dissimilarity, calculate the dissimilarity of one of those entries to another. Okay, so I need to calculate how similar each of those incidents are to each other to enable me to then group those entries based on their similarity. Okay, now the way that we do that is we use there's a method in TrainMiner called sequence distance, secdis, and we use that command to calculate this similarity. So if I pop that in, okay, so this is going to, or not in the case of me, but that will calculate the similarity between those entries within that text file, and based on that we're able to then kind of calculate the distance, how similar they are to each other. Okay, so then we can start and say actually calculate the distance between them and produce me a matrix. I'm getting some errors in my text file, but that's not a problem for what I'm trying to achieve. So calculate the distance within that text file, calculate how similar those entries are to each other, and map that. And having mapped that, then what we could do is we could go on and we could then graph those results and produce a dendrograph that would show us how similar those entries are to each other, and kind of place them in families. So if I just show you the code for doing that. Now I've commented this code out, and there's a reason for doing that, not least because my text file seems to be producing errors, which is slightly puzzling. But if I ran this particular piece of code, it would produce a very nice dendrogram, which we'll see in a moment. But if I did run that piece of code, it would take time, more time than we've got in order to do the analysis. So we calculate the sequence, we calculate how similar those entries are to each other, and run this particular code to kind of graph those results, and that gives us a very nice graph. It gives us a graph, excuse me,